Welcome to the Math Record. Today we'll be learning about the cross product. This video will cover part 5 of chapter 9 in our Precalculus class. This video will also be the last video in our Precalculus class, except for when the Math Record would be releasing mini Precalculus lessons. The mini Precalculus lessons, you don't really need to study it for this class, but that's why it's called mini Precalculus lessons. It's just if you want to know. Well, let's move on to the purpose of the video. What is the cross product? The cross product is only for 3D vectors, and don't mistake this for the cross product because for the dot product, the cross product uses a v, uses a x, so vxu, while the dot product uses viu. It's just a vector notation, so don't think v and I is the dot is the same because the arithmetic ways of multiplying. It's not the same. So this is really simple. So these actually gives you vectors and not like dot product giving you a numerical answer. So it'll be like say AI plus BJ plus CK, and U is equal to DI plus EJ plus FK. To do these, to find the i's, j, and k, the coefficients for them, you basically kind of just do like matrices. So if you want the x one, which is the i's, you ignore the a and the d, and because those are for the x, and you just focus on the other ones. So you do the matrix for BCEF, which is the same as BF minus EC. And that's for I. Plus, now if you want the J one, it's just matrix ACDF. So it's just AF minus DC. And that's for J. And if you want for the K, just ignore the K's, which is A, B, D, E. So it's just A times E minus DB. And that's the cross product, basically. This is VXU. So that's the basic idea of how cross products work. Let's move on to the algebraic properties of the cross product. Let's say that if the cross product of the exact vector is equal to 0. Because think about it, you have A, B, and C, right? And you have A, B, and C. So it will be B times C minus B times C, and then you have B, which is A times C minus A times C, and then you have C, which is A times B minus A times B. So that's why it's 0. It's based on how it works using matrices. And now also if you have the cross product of v vectors v and u, it's the negative version of when it's u cross product is u and v. So if you switch the vectors, you get to put it negative in front of it. Also, let's say you have a scalar called a, and you put the cross product of v and u. This is the same thing as saying the cross product of av and u, or the cross product of v times au. So a just goes to one of them. And if you have the cross product of a vector times a vector of a sum of two vectors, this would be vector v times u plus vector v and w. So you kind of just distribute them out. And that's the algebraic properties, which pretty much follow algebraic rules, except for some that are really weird. Now for the geometric properties of the cross product. They say that the cross product of v and u is orthogonal to vectors v and u. So if you want a vector that is perpendicular to vector v and to vector u, you just find the cross product of them. Also, if you wanted to find the let me write this first. Also, if you wanted to find the angle between two vectors, you do the cross product. The magnitude of the cross product of v and u is equal to the magnitude of v times the magnitude of u times sine of theta, where theta would just give you the angle is between u and v. So let's say you have vectors v is equal to I plus j, I plus, I don't know, 2j plus 3k. And you have u is equal to 4i plus 5j plus 6k. And then the cross product would just be 12 minus 15, which is negative 3i. 6 minus 12, which is negative 6k. And you have 5 minus 8, which is just negative 3, negative 6j minus negative 3k, right? So that's the cross product of v x u, okay? It's equal to this. Then you have to find the magnitude of this. So the magnitude of 3 squared plus 6 squared plus 3 squared, square root, that's 9, and that's 18, and that's 36. So that gets 54. So you have a magnitude of square root 54 for the cross product. Now the magnitude of v is 1 squared plus 2 squared plus 3 squared. So that's 9, 4, and 1. So that's square root 14. And the magnitude of u, which is just 16 squared, 25 squared, and 36 squared. So that's 61, that's 77. So that's square root 77 times sine of theta. Now using your calculator, square root 854 divided by square root 14 and divided by square root 77. And then you inverse sine of that, and you get about 12.9 degrees, is rounded to 10th place. So basically the angle between vectors u and v will be equal to 12.9 degrees. Okay. And also, if another thing that you could learn is find the area of a parallelogram, which is basically the magnitude of the cross product of v and u is basically the magnitude of the product of v and u, because it does something like it has the let's say this is v and this is u, right? Sorry, let me make this a little bit. Yeah, this is v and this is u, and then you make another u and make another v. This makes a parallelogram because this is equal to this and this is equal to this, and then basically the cross product and the magnitude will basically get this entire area of this parallelogram. So for vectors v and u, they're made by vectors v and u. So you just find the magnitude of the cross product. Okay. Also, they say that if they say the cross product of v and u is equal to 0, cross product of v times u is equal to 0 if v and u are parallel. And that's the only case. That basically covers like everything for cross products. So, well, and that also covers the last video for our precalculus class. Well, congratulations! You completed the Math Records precalculus class. Your efforts have finally paid off. Just know that there's still some untouched precalculus knowledge not covered in this class. Some that we're going to cover in the mini precalculus lessons, as I said before. But you now have the fundamental concepts covered. So be good. So you'll be good on those. Well, thanks for watching, and one last time, congrats on completing the precalculus class.